let's discuss this Laplace, inverse Laplace transform here. Okay, so before this, right? Before this, we have a function of ft. Okay, we apply transformation of ft by Laplace to get fs. Now we have the transform version of fs. We want to reverse back the process to get ft, where we will apply the inverse transform, okay, to get ft here. We inverse transform fs to get ft. Remember, our purpose is to have the original solution. So we have ft, we transform to fs, we find the solution in S domain, and we inverse the process by finding the original solution of T domain. So this is why we do it. Okay, why we have to implement the transformation and also the inverse transformation. Okay, so that is the process. So basically, how can we do it? Of course, you have to understand the table of transformation and also the properties that we have learned previously. So that is the only way on how can we inverse transform, right? So let's take a look at the table of transformation here. Okay, let's say here we have let's say here we have ft equals to a, then fs equals to a over s. So let's say ft here you have 5, then fs is 5 over s. Now if you fs is 5 over s, so inverse transform of fs is 5. So you want to understand this form first and you want to reverse the process. Okay, instead of ft to fs, now fs to ft. But there is no exact formula that we are going to use. Basically, before this, we implement the definition of transformation in order to transform. But this function is already transformed. So we have to know the original function of that transform version in order to get the inverse transform. Okay, so what we need to do here in order to inverse transform is to understand the function of fs first. Okay, so let's say fs is 5 over s. So you understand that this is come from a constant. So your ft is 5. Okay, so you need to understand the table of transformation and also the properties. So if your fs is fs minus a, so this is the first shifting property, then your function is EATFT. Okay, if your function of s is exponent minus as over s, then this is what? This is unit step function. This is second shifting property. This is the right delta function, and this is also the right delta function. So what is inverse transform of 1? Okay, I have explained in the video. What is inverse transform of 1? So basically, you can take a look at the right function, delta function here. Okay, transform of delta function equals to 1. So inverse transform of 1 is what? Anyone? Equals to delta t. Okay, good. So you know where this come from. This is come from the properties, that we have learned, from the special types of function that we have learned from the table of transformation. Okay, now let's take a look at this example. We have 4 over s squared plus 9. Okay, we have 4 over s squared plus 9. So based on these properties and also the table of transformation, which form is the most suitable form of fs? Is it a over s? Of course, no. Is it n factorial over s n plus 1? Of course, no, because we have plus 9 there. Okay, so which form is the most suitable? Okay, try to understand the function here. Which form is the most suitable function?
A over s square plus a square.
Which is comes from sine 80. Okay, so what you can do here is 4 over s squared plus 9 is mapped to a over s squared plus a squared, where the inverse transform of a over s squared plus a squared equals to sine 80. So you have to match this form of the function with the general form of sine 80. So as you can see here is 9, right? So if it is 9, when you want to convert to a squared, it should be 3 squared, right? So when this a is 3, this a should be 3. So you should have 3 here. But you want to remain 4 there. So you should multiply with what? In order to remain the value of 4.
Over 3.
Yes, 4 over 3. So inverse transform of 4 over 3 times 3 over s squared plus 3 squared can also be written as 4 over 3 by linearity property. You can put the constant outside. So 4 over 3 inverse transform 3s squared plus 3 squared. So as you can see, this is a, this is a, this is 3, and this is 3. So the inverse transform is 4 over 3 sine 3t. So this is your FT. Understand or not?
Yes, sir.
Okay, so next try fs equals to 1 over s to the power of 5. Which form is the most suitable form that you can match with this fs? You have s to the power of 5 alone there. Okay, here you only have s, here sn plus 1, s minus a, this one s squared plus a squared, this one all have a, this one should have exponent, this one is h, this one is a combination f and h, this one is direct, this one is combination of f and direct delta. So 1 over s to the power of 5 is matched to?
T power to the n.
Yes, so this is mapped to n factorial over s n plus 1, where you can see here that n plus 1 is 5, right? So when n plus 1 is 5, then n equals to 4. So this should be 4 factorial over s4 plus 1. But we have 1 here. We want to remain the value of 1. So you can write this as 1 over 4 factorial times 4 factorial over s to the power of 5. Right. So what is your FT? Inverse transform of 1 over 4 factorial s to the power of 5. So you just can put 1 over 4 factorial outside, where you just can inverse transform of 4 factorial s of 5. So what is your FT? Okay, so your ft is 1 over 4 factorial times t to the power of 4, right? Where 1 over 4 factorial equals to what? 1 over 4 factorial is 24, right? Okay, so this is how you get ft. Okay, try to understand C first before we discuss. Try to match with the table of transformation there. Okay, find the most suitable function of fs and inverse transform. Okay, 6 over s minus 1 to the power of 4 is split with what? Exponent 80, you only have s minus a, but there is s minus 1 to the power of 4. S minus a alone is alone there for exponent 80. Any idea? Shine is s squared minus a squared. But for this one, it's s only. All right? Okay, as you can see, the most suitable form of this fs is only fs minus a. Okay, where there is no restriction of this function for s to the power of something or not. Okay, so the most suitable form is fs minus a, where this form is s minus 1. All right, so let's take a look. So this is map to fs minus a, where transformation of fs minus a will be exponent 80 ft. So as you can see here, fs minus a is equals to 6 over s minus 1 to the power of 4, where a equals to 1. So when a equals to 1, then fs equals to, when fs minus a is 6 over s minus 1 to the power of 4, then fs equals to 6 over s to the power of 4. Okay, so can you relate the relation here? When 6 over s to the power of 4, we apply the inverse transform to get ft. We inverse only 6 over s to the power of 4, where it is quite identical with the previous example here. 1 over s to the power of 5. So this is mapped to, okay, so this is mapped to n factorial over sn plus 1, right? Where for this case, n plus 1 equals to 4 and equals to 3. Alright, so 3 factorial over s to the power of 4, right? Where here 3 factorial here is equals to 6. So inverse transform of 3 factorial over s to the power of 4 equals to t to the power of 3. Clear not? So this is ft. Now you have a, you have ft, then inverse transform of 6 over s minus 1 to the power of 4 equals to exponent ATA is 1, FT is T cubed. So this is how you do it. Okay, any question? Okay, understand? All right. Hope everyone can understand this. Any question? No question? So what you can do for this inverse transform is to understand the function given. And then you can match with the table of transformation or you can match with the properties. Okay, let's try another example. Example 18 there. Okay. A. Let's do this together. For A part here, which form is the most suitable that you can match with 2 over s minus 2 squared plus 9? You can take a look at the table in your notes and the properties. Sine 80. Sine has s squared plus a squared, not s minus 2, s minus something. So it is matched to fs minus a again. Okay. First, you have to make sure that it has the same form with the function of f in the table or in the properties. So otherwise, you can try the properties of fs minus a here. Okay, this is the only function that can match this to this function. All right? Because the rest has a unit step function where you will have a piecewise function. H and delta, unit step function or Heaviside function and delta function here consists with a piecewise function of a unit step, and also delta with a piecewise function of an infinity range. Okay, of course they are out. So what's left is fs minus a. Right. So now let's take a look. So this 2 over is mapped to fs minus a, right? Where your a should be what? A should be 2. Okay. Again. This fs is mapped to fs minus a, where when you inverse transform of fs minus a, you can have exponent at and ft. So what you need to have here is a and ft. So a is 2. So when a is 2, okay, when a is 2, then fs equals to 2 over s squared plus 9. Okay, so now this is mapped to what? This is mapped to cos, right? Cos AT, where the transformation of cos AT will have a over s squared plus, sorry, this is sine AT, a squared. So what you can do here is to do some modification with this. So this fs should be s squared plus 3 squared. And this one is 3. So the denominator should be 3. But we want to remain 2. Then we just multiply with 2 over 3. Okay. So ft is equals to inverse transform of 2 over 3 s squared plus 3 squared. So this 2 over 3, by linearity, you can put it outside. So you just can inverse transform of 3 over s squared plus 3 squared. So you can have 2 over 3 sine 3t. So this is your ft. Now, coming back to this. So, inverse transform of 2 over s minus 2 squared plus 9 equals to exponent a is 2 multiply with ft. So you can have okay, clear now? Anyone ask question? Okay, all clear. All right, try B. This is also mapped to fs minus a. So how can you modify the form of this function of s? Okay, try B. Okay, so let's discuss this. You should know that there is no form in the table of transformation here that can match to this 2s plus 5 cube. Okay, so we have 2s plus 5 bracket to the power of 3. So this one is s squared, this one is only s minus a, s squared, s squared, s squared. This one is direct, heavy side, heavy side. So the most suitable one is fs minus a. So first you have to modify, you have to map these two fs minus a, where you know the inverse transform of fs minus a equals to exponent at times with ft. So what you should have is your a and your ft. So you modify this in terms of fs minus a. So fs minus a should be 3. This one is 2, right? 2 s minus 5 over 2 cube. So we want this function in the form of s minus a. So this is 2s. We cannot just 2s minus 5 because we have to have s only. So we factorize 2. We put 2 outside. Okay, and then s minus 5 over 2 because we don't want to change the original value. So this one we can rewrite as 3 over 2 cube is 8 s minus 5 over 2 cube. So when fs minus a is 3 over 8 s minus 5 over 2 cube, then you can know that your a equals to what? Your a equals to minus 5 over 2. So from here you know your fs equals to 3 over 8 s cube, right? Then from here you can find your ft. So this fs equals to 3 over 8 s cube. Now in order to find ft, you need to map to the suitable function from the table of transformation here, which comes from n factorial over sn plus 1, right? Because we have 8s cubed. So we just can put 3 outside here. Okay. Now n plus 1 equals to 3, right? Map this with n plus 1. So n equals to 2. So what you should have here is s to the power of 3. This one is 2 factorial, but this one is 1. So we want to remain 1. Just multiply this with 1 over 2 factorial. Okay, clear not? So ft equals to inverse transform of 3 over 8 times 1 over 2 factorial is 1 over 2, 2 factorial over s cube. So this one will become 3 over 16. Put this outside. Okay. Inverse transform of 2 factorial over s cube. We will have ft equals to 3 over 16. This one comes from t to the power of n, where n equals to 2. Is that clear now for this part? Any question? Right? So you got your ft already. And you know what is your a. So back to the first step again. Then inverse transform of 2 over of 3 over 2s plus 5 cube. We will have exponent a t a is minus 5 over 2t times with your ft, which is 3 over 16 squared. So your ft equals to Clear? Are we good? Understand it all here? So from 1 to 10, where are you? Okay. Right. What about the rest of you? Understand it all?
Yes, I can.
Okay. So that is how you inverse transform directly based on table of transformation and also the properties. That's why you need to understand first how to transform. How to transform basically based on the definition and the table of transformation and also the properties. Okay. So next, try the next one. We can also find the inverse transform by using partial fraction. Okay. All right. So the next one, still, we are going to find the inverse transform. But what if that function is quite complicated in order for you to simplify? Okay. Where you cannot directly understand the function based on the table of transformation and also the properties. So what you need to do here is to simplify the function first by using partial fraction. Okay, so let's take a look. Just like this example, as you can see, 3 over s plus 1, 3s plus 1 over s squared minus s minus 6. There is no function in the table of transformation and also the properties that can map to this function. So you know that this is quadratic function and this is a linear function. We have to simplify this by using a partial fraction. And I believe all of you has learned about the partial fraction, where there are few types of partial fraction that you need to know here. All right. So if your denominator, so the types of this partial fraction is referred to the denominator. Okay. So when the denominator is a single or a linear factor, then the partial fraction is a over s plus a. And when the denominator is a repeated factor, then the partial fraction is written like this: s plus a plus s plus a squared. So this is a repeated factor. This is a linear factor. Okay, and then if you have a repeated factor up to 3, up to 4, then it is repeated s plus a squared, s plus a cubed, s plus a to the power of 4, and so on. Okay. First, it is a linear. Second is a repeated up to power of 2. This one is again repeated up to the power of 3. And if the denominator cannot be simplified, so instead it can only be written as a quadratic, then the partial fraction should have a linear function in the nominator. Okay, and then when it is a repeated quadratic factors, it is a quadratic and also it is a repeated factors, then just repeat the factor but with a linear nominator. Okay, let's take a look at the example here. We have 3s plus 1 over s squared minus s minus 6. First, what you need to do is to simplify, is to factorize. You can use your calculator. Is this s squared minus s minus 6 can be factorized directly based on your calculator? If yes, then you just can write the factor in terms of s plus 2, s minus 3 for this example. So, as you can see, the factor is s plus 2 and s minus 3. It is a linear factor. So, you can simplify this to a over s plus 2 plus b over s minus 3. Alright, so when it is a linear factor, then the denominator has only constant value. So what you need to do is to find value of a and b. Okay, is that clear now? All of you have learned the partial fraction, right? Okay, so from here, you need to find a and b. Okay, so how to find a and b? Just make sure the denominator is equal. So a multiply s minus 3, b multiply s plus 2, and then compare with the 3s plus 1. And you can have your a and your b. Okay. Once you have your a and b, so what you can say here is 3s plus 1 over s plus s squared minus s minus 6 can be simplify by using partial fraction of s plus 2, s minus 3 by using a over s plus 2 plus b s minus 3. Find a and b, compare with the left hand side here, and it can be simplified to 1 over s plus 2 plus 2 over s minus 3. So this is actually your fs. Now, in order to find ft, you have to inverse transform one by one of this. Okay, so map to the table of transformation, s plus 2, s minus 3, it is mapped to exponent minus 2t. This one just put 2 outside plus 2 exponent 3t. Because exponent fs equals to 1 over s minus a for ft equals to exponent 80. Just map to the table of transformation here. Exponent 80 is 1 over s minus a. Now we have 1 over s plus 2. That's why this one exponent minus 2t. Then this one 2 put outside by linearity property. We have 1 over s minus 3. So exponent 3t. Is that clear? Any question? All right, good. Okay, so basically what we are doing just now is still find the inverse transform. But when the function need to be simplified by using partial fraction. So before this, we just can take a look at the function, understand the form of the function, which types or which form that it is mapped to, and you inverse. Now, this function is is not simple as the previous one. So you need to simplify first. So how can you simplify? By factorize and do the partial fraction. Once it is simplified, then again you have to take a look at the table of transformation and the properties. All right. So basically it is the same process. Okay, now let's take a look at this. So tips when dealing with the fractions. So if the denominator is a quadratic, okay, first what you can do is try to factorize. Try to use your calculator. If it is doable for you to factorize, then you just can factorize. If you have a linear factor, then you can have a constant as your nominator. Okay, if it is possible, then proceed with the partial fraction decomposition. If not, we can apply the completing the square method. Okay, so now let's try example 19. At 5s plus 1 over s squared minus s minus 12. Can you simplify this or not? This one can simplify to what? S plus 4, s plus 3, right? S minus, sorry, s plus 3, s minus 4. Okay, so what should the partial fraction of this form can be? So we can decompose to what? What is the denominator here? Anyone? So the denominator is what? This is a linear single factor. So what is the denominator here? This is the first type of partial fraction. Anyone? Come on. Just the form. No need to solve. You can try to do it after this. What is the form? Okay, you get the value of A and B. Okay. So this is a linear factor. So you can decompose to A over S plus 3 plus B over S minus 4. Okay. So from here, as you can see, Li Zong has solved the value of A and B, where you have A equals to 2, B equals to 3. Then you just can find the inverse transform. Find A and B, you got A is 2, B is 3. So what you can do here is this Fs, in order to get Ft, you just can inverse the function of Fs there. Alright, so this one becomes 2 exponent minus 3t plus 3 exponent 4t. So this is how we do it. Okay, when the function is cannot directly be mapped to the table or properties, you have to simplify or factorize. You use your partial fraction, and then you can again try to inverse. All right, so this is how you do it. Okay, try second one. So this is s plus 1 is a linear factor. This is s squared plus 4 is a quadratic factor, where these two factors cannot be simplified anymore. So it can be decomposed to what? A over s plus 1 for a linear factor. This is a quadratic. Bs plus c over s squared plus 4. So you need to have to find A, B, and C here. Okay, and then you can try to inverse transform. Try. Okay, and then the third one. Okay, let's discuss this first. The third one cannot be factorized directly, so you can try to completing the square. You can try to apply the completing the square method, okay, where you should have here 2s minus 3. This one, by completing the square, we can have s plus 1 squared plus 16. And then map to fs minus a here. Okay, try to find the inverse transform of these two examples. Let's try these two examples, whether you can do it or not. Okay, is that clear? So from here, the function here cannot be simplified directly based on quadratic or based on formula of quadratic. So you can try to completing the square. Okay, by completing the square, the denominator here now is simplified to this, where this function is mapped to fs minus a. Okay, when it is mapped to fs minus a, the inverse transform of fs minus a equals to exponent at and ft. So you have to know what is your a and what is your ft. Alright, so basically from here, you know that this is mapped to fs minus a, so you need to do some modification of s there. So you have to make sure that both s variable is in terms of s minus a. Okay, where s minus a here is s minus minus 1. So this s also should be in terms of s minus minus 1. So when you create s minus minus 1 here, you have to make sure that the original function is not changed. So you just put another value here to make sure that there is minus 3 there after you expand. Okay. So once you can have in terms of fs minus a, so basically this function can be written to fs minus a by putting s minus minus 1, s minus minus 1 for both s variable. So when they are equal, then it can be easily to change from fs minus a to fs. So when fs minus a is this, you know the value of a and you can have your fs. So from here, you inverse transform one by one and match to the table of transformation, simplify and inverse transform to get ft. So once you got your ft, again, you come back to this. Again, you come back to this. Right, then you know your a is what? Your a is minus 1 and your ft here is what? So this is in terms of exponent at times with ft. This is your ft, this is your exponent at. Okay, clear not? All right. Okay, good. So I hope everyone can understand how can we inverse. So you need to have a lot of exercise here because we have a lot of function type. You need to understand the function, where it is mapped to, how can you modify, how can you simplify. So we have what? We can simplify by using partial fraction, completing the square, even long division can also be applied, but try to understand the function first. So what method that you can do, that you can use to do the simplification and modification. Okay. So basically from the video, I have recorded up until convolution theorem. So I want to proceed here. And then I will leave you with the exercise because convolution theorem is quite easy and simple. Okay. Any question for inverse transform based on table of transformation, based on properties, simplified by using partial fraction, and also completing the square. So we just now have done those parts. Any question? So from 1 to 10, where are you right now? Okay, 8, 7, 6, 6, 6. That's it. How about the rest of you? We have how many participants here? 38. It's okay. Don't be shy. We are all learning here. Okay. So basically, this inverse transform need you to understand the function. Okay. And of course, you have to know, you have to master with how to transform first. Okay. How to transform by definition, by properties, by special types of function. Once you understand, you can understand the table of transformation and properties. It is easy for you to inverse transform. Okay. We have to apply the inverse transform here by using the table of transformation, the properties, by simplifying the function using partial fraction, using what we call completing the square, and also you can use long division as well. Okay, but now the most important part is to understand what is mapped to the function that you have there. Okay, now let's try the next one. So inverse Laplace transform here can also be evaluated by using this theorem, convolution theorem. But, all right, so now are we ready to proceed? Okay, another topic, one topic. So now how can we inverse transform by using this theorem? So before this, we just have Fs. Let's say Fs 1 over s minus 3. Then inverse transform of Fs, we will have exponent 3t based on the table of transformation directly. Okay, now this convolution theorem can be used to find the inverse transform, but with only the combination of two functions. For this one, we have only one function. But let's say you want to create another function. So 1 over s minus 3 multiply with 1. So another function. Right. But this one is easily for you to directly transform based on the table. No need to use the theorem. But what if you have a combination of two functions just like this? 1 over s times s squared plus 4. Then for this case, we can use convolution theorem. So how can we use convolution theorem? So let's take a look. Inverse transform of Fs gs can be found by integrating from 0 to t fu gt minus u du. So now, for this case, what is your f? What is your g? All right, so either way, any function can be your f, any function can be your g. So let's try. So for this case, let's try this as your 1 over s as your fs, and gs equals to 1 over s squared plus 4. Okay, so this convolution theorem can be used with the condition of combination of two functions. So fs and gs. So fs for this example is 1 over s. gs is 1 over s squared plus 4. All right, so now from this fs, you know that you can inverse transform to get ft. So when fs is 1 over s, what is your ft? Okay, come on. When your fs is 1 over s, what is your ft? So ft equals to 1. This is a constant. When ft equals to 1, of course, fu also equals to 1 because this is a constant. Let's say ft equals to exponent to t. Then fu equals to exponent to u. But now ft equals to 1, a constant. So fu also equals to 1 because these are a constant. Okay, so settle with f. Now gs. So when gs is 1 over s squared plus 4, then what is your gt? Gt equals to what? Directly transform based on the table there. This is s squared plus 2 squared. So you need to have 2 here, right? But we want to remain 1, so multiply with 1 over 2. So gt equals to what? Right, good. So 1 over 2 sine 2t. So when gt is 1 over 2 sine 2t, then gt minus u equals to 1 over 2 sine 2t minus u. Alright? And then we want to find inverse. So inverse transform of 1 over s squared plus 4 now can be found by integrating from 0 to t. Fu is 1. Gt minus u is 1 over 2 sine 2t minus u. Integrate with respect to u. Okay? Clear not? So this is 1. This is 1 over 2. Just put 1 over 2 outside. Integrate this only. So what should you have? Sine 2t minus u. So integrate with respect to u. So you should have negative cos 2t minus u over minus 2, right? This is my 2t minus 2u. Integrate sine negative cos. So differentiate minus 2u, give you minus 2. So from 0 to t. Okay? This one is will give you what? Cos 2t. So substitute to u. 2t minus t minus cos 2t minus 0. Okay, so cos 0 equals to 1 cos 2t. Right? Clear not? So this is how you obtain the inverse transform. So this is your f. All right. So you need to understand what is your function of s of f, fs first. Okay. What is your f? What is your g? Find ft, find fu, find gt, find gt minus u, and then just substitute to the formula here. So integrate from 0 to t fu times gt minus u, integrate with respect to u, apply the limit, and this is your ft. This is how you find the inverse transform by using convolution theorem. Is that clear?
Yes, sir.
Okay, anyone has question? You have question? You have problems or not? All clear? All right, good. So this is how we do it. Finding the inverse transform. Basically based on table or properties or understanding the special types of function. And also we can implement the partial fraction. Okay, factorize the denominator, quadratic, completing the square, and then we can also find the inverse transformation by using convolution theorem. Okay, so now you have done with how to transform and how to inverse transform. So I hope you can try the rest of the exercise before we can proceed with applying the transformation here to solve the differential equation next week. Okay? Anyone has question before we start? No question. All right. Thank you. So I think that's it for today. So let's end our class with Suratul As and Tasbih Farah. And don't forget to scan this attendance. Okay, guys. Thank you. Assalamualaikum.